Hello, in this lab we will be scaling Kubernetes deployment up and down. Means we will be deploying a web application on the Kubernetes cluster, and to adjust the number of incoming requests we will be scaling it up or down. So to adjust the incoming request and distribute them into the number of pods. So what we will be doing in this lab, first we will be building the Docker image of our web application. That is what we have to deploy in the Kubernetes cluster. So that we will be see what is difference between Docker image and Docker file and container. So then our Docker image is deployed. Now we create a service resource so that a virtual IP is provided at the front end of our web application. Means a virtual, not a public IP of the cloud is used. So a virtual IP is assigned to access that web application by the outside environment. That is we can see from the browser if we have to access. A virtual IP is assigned so that all the incoming requests access the web application through that virtual IP. So we have created a new service resource. Then that service resource means that virtual IP will distribute the incoming traffic into number of pods. Then we will scale up and down the deployment using increasing or decreasing that number of pods. So pods is nothing but a single executable unit, and we will see lot of that and difference between pod and other things in detail in this lab. And then we will test and validate the container setup using the curl command. Curl command is nothing but we can see here that it is a command line tool that enable data exchange between device and service through the terminal. So we will be analyzing that how many curl command will be analyzing the scale up or scale down by using the curl command and exchange data between our web application. So that's the objective of this lab. Now we'll be coming to the brief overview of the lab. So this is the first step where we have to deploy our web application, Docker image of our web application into a namespace. So first we will be seeing what is Docker image and Docker file, and what is namespace. So Docker image is nothing but a snapshot or template that create all the extension or requirement or resources that are needed to run a container. That is in a Ubuntu image, there is Ubuntu is present in the Ubuntu image. Docker image means Ubuntu template, and in MySQL it is running on Ubuntu. So MySQL plus Ubuntu Docker image is also needed. In Java plus Ubuntu is needed. Similarly, for any application which is running on Node.js, MongoDB, and the operating system on which it is running. So all the resources or requirement that are needed to run that web application, that is contained in the Docker image. That is template or requirement and sources. So what we'll see what is Docker file. Docker file is nothing but code of the requirements that is needed by the container to run the application. So if we see here, like in this application, it is main.py, means it is the code which is getting executed. Now Docker file of this is starting with the Python 3, means it needs Python 3 and install Flask. So these are the requirement that is needed by this. The code of this is called Docker file. Now this requirement are satisfied. This requirement are mentioned in the Docker image. So it will then build Docker image, and all the requirement are pulled from the Docker registry, which contain the Docker images of all the things. Like one application of Docker image need Ubuntu operating system and other things. So that will be fetched from this Docker registry, and all the container are then run on this Docker image. So whenever a container has to run, the container use this Docker image to run and fetch all the requirement and resources to run the application, that is to run the container. So all these things are provided with the Docker image which is mentioned in the code. So Docker image is just a template and snapshot that contain all the requirement and resources, so that we can see. And now see what is namespace. So here is a mentioned that namespace is a way to organize cluster into a virtual subcloud. Means it is nothing but we can say that we have one big cluster, so we have distributed the cluster into the subcluster using the namespace, which is default namespace, dev namespace. In default namespace there is app1, in dev namespace means we have distributed our application into a different namespace in a one cluster. So it is a way to organize cluster into virtual subcluster. So now we have analyzed what is namespace and what is our Docker image and Docker file. So same thing is given in this lab. We have provided with Docker file and main.py, and then we will create the Docker image of this. First we will list what are things present and build the Docker image. So we will first build the Docker image of this file, and then examine all Docker images available. That is all the requirement that is being provided for this. And then we created a Kubernetes namespace. That is, we have seen a virtual subcluster inside our cluster. So we have created a Cloud Academy subcluster and make that a default namespace and created a deployment resource name frontend. Now we have created a deployment resource for the frontend. That is, we can access this web application using this frontend and having replica to and image pull policy. These things are present in that. So we have created a deployment and examine the current deployment within the cluster, which we can see here ready and available to, which we have set here to replicas and get all the ports available. That is all the resources. Now we will first create a service resource so that we can get access to this deployment using a virtual IP provided by us, and then we will increase or decrease the pods to get access to this web application. Now we have seen what is a service resource. So means service resource create a stable cluster virtual IP that sit in the front and distribute incoming requests across all ports. So it will sit in the front end and distribute all incoming requests to the pods. So it is abstraction of it. We can see it is logical abstraction of the deployed deployed group of pods in cluster. It consists of number of pods and assign them to a virtual IP to access the front end of the application. So it sit in the front and distribute incoming request across all ports. So first we expose the front end deployment with the port mapping we have mentioned and examine the current services running within the cluster, and then extract the cluster IP of the front end using this command, and then we perform a test call command. The call command we have seen, it is a command line tool that enable data exchange between device and service through a terminal. So we are testing that our things are working fine. So our front end IP is working fine, which the virtual IP which we have assigned in the range port mapping of this to this. So now it worked fine. Now we will increase or decrease the number of pods to scale up or down our cluster. So now first we scale up the our front end deployment. So for that we will increase the pod count from 2 to 4. So the command for increasing the pod count will be Kubernets scale deployment. We increase the replica to 4, and then we check how many replicas, how many pods are running in our Kubernetes cluster, which we can see, and we can see here 4 pods are running, and then we describe the endpoint which are for these Kubernetes cluster, means the endpoint which are redirecting, means the pods are redirecting to a specific web application. So the endpoint is mentioned here, and then we use multiple call command to check if the application is working fine. So we have used the for loop to send the echo call command again and again. So for 10 the hello world will be printed, hello world Kubernetes. So our things will be working fine as we increase the number of pod and scale up our deployment. Now we will be scale down our deployment using the by decreasing the number of pods from 4 to 2. So this we have done. Now we examine the pods that are running. So we can see here that the number of pods have decreased. Now only 2 deep pods are running, second and third. The first and fourth have been terminated. So we can scale up or down Kubernetes cluster using this. So in this lab, first we have seen that we have scaled up our deployment and then scale down our deployment, and before that we have seen how to build and deploy our Kubernetes cluster and the difference between Docker file and Docker images that we have seen here. What is Docker file? It is a only code present in that, and images are just a snapshot and abstract view presented and pull all the requested resources required for a container to run. Then we also see what are namespaces are way to organize cluster, and what is pod is smallest executable unit in a cluster, and Kubernetes pods are abstractor of generalized container. We also seen it is a level down. We also seen what is Kubernetes service. It is logical abstraction, and then we also see how a service resource create a stabilized virtual IP that sit in front and distribute incoming requests across all ports. So we have scale up and down our application using by decreasing or increasing the number of ports. So that's all for this lab.